Okay, today's lesson we're going to do exercise 9G, differentiating powers with fractional indices. Now from the previous lessons, we did differentiating powers with negative indices. Now for the fractional indices, the formula is still the same. You still drag the power to the front and then minus the power by 1. And there's no difference between the formula. So I'm just going to try a few questions from the exercise, all right, to show you like in more sort of like towards the application type. And whenever you see some like a slightly difficult problems, what is the best way to deal with it? Obviously, in exam, they're not going to provide you a question that's straightforward, give you a fractional, give you a fractional indices and ask you to differentiate it that easy. So I'll start to pick some beginning question to start with, and then we're going to move on to something that's a bit, a little bit challenging, and we'll go from there. So I guess the first question I would like to do is question 9b. Okay, so question 9b, this question here. All right, so according to what the question asks you to do is they ask you to divide the numerators by the denominator, then differentiate it. Obviously, this is the steps you need to be able to do when you encounter a question like those. If you see a fraction like this one here, and you do have another option which is quotient rule, but usually the quotient rule is much harder to deal with it, okay? And for this one, it's just easier if you can divide every single term by x. Eventually, you are going to get a fractional indices, and so you use the same method to differentiate it. All right, so let's start with this question here. Right, so this is question 9b. Y is equal to x squared plus 6x square root of x plus x over x. All right, so the first step to do that question is instead of differentiating it, you want to simplify this. You want to divide every single term, all right, so every single term here by x. All right, so this is what we do. All right, so that gives you x plus 6 square root of x plus 1. So that's pretty easy. Now, once you have finished this part here, then the next step is to change that square root of x as a power of half. So that gives you x plus 6x to the power of half plus 1. Okay, once you finish that, now you can start to differentiate it. All right, so dy over dx is equal to 1 plus, in order for you to differentiate 6x to the power of half, remember the steps here is just move the half to the front and minus half by 1. All right, it's the same method here. So that gives you 3x to the power of minus half and plus 0. The derivative of a constant number is just equal to 0. So at the end, your final answer will be 1 plus 3x to the power of negative half. It is your decision whether you want to change that power of negative half back into the positive powers, even like in terms of square root. For me, I'll just leave the answer like this one, unless there's an advantage of changing it. Maybe I need to solve certain questions, or if I need to solve for equations, then in that case I'll change it. Otherwise, I'm going to just leave the answer for the derivatives. So that's exercise 9G, question 9b. Okay, pretty straightforward. All right, let's find another question to do. Question 10. Looks like question 10 is pretty interesting. Use the full setting out of a chain rule to differentiate each function. Then I'll find the coordinates of any points where the tangent is horizontal. All right, the question says use the full setting out of the chain rule. When I deal with the chain rule question, I never really use the full setting out where you have to write down dy over dx is equal to dy over du times by du over dx. But here comes the question that asks us to use it. Well, unfortunately, let's just use it. Then the question says find the coordinates of any point where the tangent is horizontal. So that means the derivative is equal to 0. All right, so just to focus on question 10a, use the full setting out for the chain rule. Okay, so let's start. 10a, y is equal to the square root of x squared minus 2x plus 5. All right, so let's start with this one by changing this square root into a fractional power. All right, that's to the power of half. Once you have finished that, the next step is we are using the full setting out, all right, for chain rule. Now remember, I'm not going to do this one in exam for the full setting out for chain rules, all right? I refuse to do it. It's really inefficient. But since the question asked me to do it this time, so I will show the full setting out for the channel, but I still feel like this is not the best method to use, all right? So I will let u equals to x squared minus 2x plus 5. So you're replacing what's inside this bracket by another function, which is u. So once you have finished that, what you are getting is you get a two function. Now y is equal to u to the power of half. So these are the two functions you have. This function here is the function of u in terms of x. This function is y function in terms of u. Okay, so we can use the full setting of channel to actually, differentiate this function there. So let me just highlight this one first. Okay, right. Now, there's two functions. So the first one is I'm going to differentiate u function with respect to x. So therefore, that will give us du over dx. This time, please write down a notation like this. Du over dx is equal to, all right, so you differentiate the u function with respect to x. That gives you 2x minus 2. That's du over dx. And then on the other side, y is equal to u to the power of half. That gives you dy over du. Now be careful, it's not dy over dx. Because on the right hand side, it's in terms of u. That's the prenumeral here, so it's dy over du. Alright, so dy over du is equal to half u to the power of minus half. Okay? Dy over du is equal to half u to the power of minus half. Alright, now what we need to do is we need to find a way to actually combine the two derivatives together to find dy over dx. So if we combine them together, we know that from the channel, dy over dx is equal to dy over du times by du over dx. Okay? Alright, so now once you know this one here, then we can simply just do a substitution. We know dy over du, okay? So dy over du is equal to half u to the power of minus half, and then we times by du over dx, which is 2x minus 2. All right, and at the end, all we have to do is replace the u by the substitution we have before, which is x squared minus 2x plus 5 to the power of minus half, and then 2x minus 2. Okay, all right, once you finish that, probably you can also times the half to the second factor, which, as you can see, that's half, that's a 2 and a 2 here, so you can cancel 2 and 2. At the end, your answer will be x minus 1, x squared minus 2x plus 5 to the power of minus half. And that becomes the answer. And this is the full setting out for the channel. Again, I never use that method to actually differentiate it. I just used the quick method to differentiate this one using the shortcut of channel, which is just this formula. So if you have fx to the power of n, then the derivative of that is equal to n. You move the n to the front. Okay, minus n by 1, like your usual derivatives, all right, and you multiply by the f dash x. Okay, so if you look at this, I'm just going to highlight that for you so you can actually see these terms are very similar. So basically, fx is the function inside, which is that function there. Okay, that's what fx is. And then n minus 1 is the number that you have. Previously it's to the power of half, so therefore now it's negative half because half minus 1 is negative half. Then of course you actually move the half to the front, that's what n is equal to. At the end, the most important part is the channel bit, which is the 2x minus 2, and that is the derivative of what's inside the bracket. So if you pay attention to that, the derivative of x squared minus 2x plus 5 is 2x minus 2, and that's where the channel is. Okay, so therefore you can actually use this formula to do the differentiation much quicker than using the full setting out. All right, okay, but you do need to know the full setting out for certain question later on when it comes to rate of change questions. So please do remember how to use the full setting out channel to set up, the derivatives in terms of, question like those. Okay, so that's question 10. All right, so let's move on to something like, it's more towards an application type, okay? Let's do maybe we can do question 14a, okay? Let's do question 14a. I will leave question 14b for you to do. Question 14a. Let the point P, I'm just going to put this one here. All right, let the point P, which is a point line on a semicircle, okay? Let a point Q line on a curve, all right, which is half of an ellipse. Find the equation of tangent at P and Q and show that they intersect at, they both intersect on the x-axis. All right, okay, so let's just write down all the information we have, all right? So that's obviously the first step you do the questions, all right? Write down all the information. Question 14a. So we have a point P, and that point P, 4 and 3 is on the semicircle, all right? Y is equal to square root of 25 minus x squared. And then we've got point Q, all right, is line on this curve here, which is a semi-ellipse or half ellipse. All right, okay. And then we just need to find equation of tangent at point Q and point P on the same, on the, x, pretty sure on the x-axis. Okay. All right, so let's start with this question. So again, the way to do this question is pretty straightforward. We just need to find the equation of tangent from here and equation of tangent from there. And then we just need to find the intersection point between the tangents. All right, so let's just start. Okay, I'm just going to label this equation 1 or equation 2. So from part 1, all right, y is equal to the square root of 25 minus x squared. So y is equal to 25 minus x squared to the power of half. And then dy over dx is half. So this is just using the chain rule, all right, not the full setting out. Don't use full setting out for chain rules here. All right, so you move the half to the front. All right, you copy everything inside. You minus half by 1, which is negative half, and then you times by the derivative of what's inside the bracket, and that's minus 2x. All right, so to simplify this, that gives you minus x, bracket, 25 minus x squared to the power of minus half. All right, so once you have finished this, then you need to substitute to find the gradient of tangent. Okay, so m tangent at point 4 and 3 is, now you just need to substitute the x coordinate into here and there to find out what is the gradient of tangent. Okay, so that gives you minus 4, 25 minus 16 to the power of negative half. I wish I have a calculator with me right now, but I don't. So that's minus 4 times by 9 to the power of minus half. And that should give me negative 4 times by, negative means reciprocal, half means the square root, that means it's 1/3. So the final answer is negative 4/3. All right, hope this is right. That is the gradient of tangent at this point. Now we just need to find equation of tangent. All right, so the equation of tangent will be the y minus 3 is equal to minus 4/3, x minus 4. Okay, so that's the equation of tangent. You can expand and simplify. That is 3y minus 9 is minus 4x plus 16. I'll just multiply by everything, both sides by 3. And obviously you expand the bracket on the right-hand side. So that's 3y plus 4x is equal to 25. All right, here we go. That is my first equation of tangent. All right, so once you finish that, all you have to do is repeat the same process for part 2. Find the equation of tangent for the second function, all right, at point Q. So let's start with that. All right, part 2. Y is equal to 3/5 square root of 25 minus x squared. Okay, all right, so we need to first simplify this. 25 minus x squared to the power of half. All right, so dy over dx is 3/10. 25 minus x squared, negative half, times by minus 2x again. All right, so if you simplify that, that gives you minus 3/5. Oh, missed x. 25 minus x squared to the power of minus half. All right. Again, we need to find the equation the gradient of tangent. So mt at q is substitute, pretty sure you substitute 4 again. Yep. So you substitute 4 one more time. I really need a calculator. Okay. And then times by 25 minus 16 to the power of negative half again. All right, so that's negative 3 on 5 times by 4 times by 1 on 3. So that's negative 4 on 5. Okay, not that bad. All right, so that is the gradient. Now I need to find the equation of the tangent. So I need a point. Okay, 9 on 5. So y minus 9 on 5 is equal to negative 4 on 5, x minus 4. All right, times both sides by 5. 5y minus 9 is equal to minus 4x plus 16. So 5y plus 4x is 25. All right, here we go again. All right, so we've got two equations. All right, these are the two equations of tangent. Looks pretty good, all right, so far. So let me just rewrite these equations here. All right, so the first equation of tangent is 3. Can't remember that. 3y plus 4x. All right, 3y plus 4x is equal to 25. The second equation is 5y plus 4x is equal to 25. All right, so we need to find the intersection points, okay? So 2 minus 1, all right, is 2y plus 0 is equal to 0. So y is equal to 0. All right, whenever you show y is equal to 0, that clearly tells you the intersection point, no matter what is x equal to. I don't care about x anymore. If y is equal to 0, that means the intersection point is on the x-axis. All right, so therefore the intersection point, now if you want, you can find x coordinates, but there's no points, okay? The intersection point, all right, is on the x-axis. All right, since y is equal to 0. Okay, so that's how you do question 14a. Not that hard if you follow the question, all right, and if you follow the step-by-step working out, you should be able to just get the answer like this. Okay, good. Now let's have a look at the enrichment question. Yeah, maybe I can just do question 16a, and you can do 17a and b. Okay. Okay, so have a look at 16a. It says develop a three-step chain rule. Three-step chain rule for the derivative dy over dx, where y is a function of u is a function of v is a function of x. Okay, that's very interesting. So we've got a y function, but it's a function of u, and u is a function of v, and v is a function of x. And it hence differentiates. Okay, all right, so let's start. 16a. So we have a y is a function of u, and then however u is a function of v, and v is a function of x. So this is what happens. All right, so you have like a composite function where three functions join together. All right, and they ask you to actually develop a derivative or a chain rule for that functions there. All right, let me just rewrite this. All right, this looks ugly. So y is a function of, can't remember again, u, which is a function of v, which is a function of x. Okay, all right. So to do this one here, I'm just going to show you the quick way to do that. The dy over dx is equal to, well, I'll show you two different ways. All right, the way I would do it is u dash vx times by v dash that, and times by x dash. Okay, that's the channel I would do. Okay, that's the channel. But if you do want to write properly in terms of channel formula, it will be dy over dx is equal to dy over du times by du over dv times by dv over dx. Hope that's right. Let's have a look. If we just cancel the u and v and v here, dv over dv here, so you end up with dy over dx, which is on the left-hand side. Okay, perfect. All right. Now, you need to use the formula to differentiate that, which is really strange. All right, I know how to do the derivative, but probably, yeah. don't really need to use the full version of that formula to differentiate that. You just need to know there is a function inside another function inside another function. So I'm going to show you like what does that mean, all right? So the first function is those, all right, this one. That is the first function. The second function is that one there. The third function is what's inside, okay? All right, so to differentiate that one, pretty easy. First step, change that, or actually, let's do as a power. All right, and another power of -1. All right, so therefore dy over dx. Now, the first step, you differentiate the entire function. So you move the -1 to the front, -1 there. That's -2. All right. Then you times the derivative of what's inside. Actually, just that one there, which gives you half 1 minus x squared to the power of -half. And last one is you differentiate now the inner bracket. It's like in peel and onion, all right? You start from the outside shell and then it goes to inside. So that becomes -2x. Okay. All right, so that's it. So if you want to highlight it, okay, so dy over du is that part there. That's dy over du. Du over dv is that one there. And the last one, dv over dx, is that last little bit. All right. So once you finish that, you can actually simplify this. All right. I can cancel this negative with that negative there. These two negative cancels out. The half and 2 cancels out as well. So at the end, you get 2. No, there's no 2. You get x. 1 minus x squared to the power of -half. And then 1 plus 1 minus x squared to the power of half. And all of them raised to the power of -2. If you do want to write in terms of fraction, you can. Otherwise, I'll just leave the answer like that. Okay? All right, so that's question 16a. You can definitely do the generalized literature to the n steps, which is just continuous of the function here. So that's not hard. All right, I think that's it. I've tried enough questions for this exercise. You should be able to continue to do those questions from this exercise now. All right, thanks for watching.